Good morning, guys. My name is J. Venkatakondareddy. This report documents my enriching journey during the Emertxe Embedded Systems Internship, where I delved into the world of embedded systems and gained practical experience. Embedded system is a combination of any hardware and software which is intended to do a specific task. Or an embedded system is a microprocessor or microcontroller based system, hardware and software designed to perform dedicated function with a larger mechanical or electrical system. These are the examples of embedded system. One is microwave oven and another one is GPS system. The embedded system is mainly work with the C language. So this is the brief introduction about the C language. C language is a general purpose language and it has the efficient on portability. This is the basic anatomy of C language. Hash include stdio.h is the header file of the C programming language and printf is the body of the C language. This is the basic data types in C language. There are two data types. One is integral data type and another one is floating point data type. In integral data type, it is divided into another two parts. One is character and one is integer. Character stores like alphabets, spaces and special characters, and integer is used to store the integer values. And also floating point is also further divided into two types. One is float and one is double. Embedded C conditional constructors. There are two types of constructors. One is iteration constructor and another one is multi-iteration constructor. In single iterations, it is like statements performed in a single attempt, like if and its family, like if else, else if, nested statements, switch case statements. It performed only one time when the condition is true. In multi iterations, it performs multiple times until the given statement is true. For example, like for, while and do while. These are the basic operators in C language. The first table tells about the arithmetic operators like multiplication, division, modulo. Modulo means which gives the remainder of the two numbers, addition and subtraction. And second table tells about the logical operators, that is logical not and logical and logical or operations. C pointers. Embedded C programming often heavily relies on pointers to effectively manipulate hardware registers and manage memory, making them a fundamental concept in the domain. Understanding and mastering pointers uses is crucial for effective embedded systems development. Pointers are to achieve by passing by the variables or passing by the references. These are the basic structure of the pointers in C language. Microwave oven. Microwave oven is used to heat the food by using the electromagnetic waves. In generally, microwave consists of four modes. One is micro mode, grill mode and convection mode and start mode. Mainly the micro mode. The micro mode is used to cook food in a traditional way. It uses a maximum power of 900 watts. In this, the maximum time that you set for cooking is 60 minutes. The another one is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is used to cook meat and bread. User can set time as per the cooking time of the meat. In convection mode, in this mode, user can set oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. After the preheat is done, the user can set the time as per the requirements. These are the basic component the microwave consists by using the embedded systems. Microcontroller, we used PIC16F877A microcontroller, and then matrix keyboard, 7 segment display. A 7 segment display is a visual output device used to display numerical digits and some alphabetical characters. It consists of 7 individual LED segments arranged in a specific pattern. Cooling fan. A ceiling fan is a common household application to provide air circulation and cooling. It is typically has a motor blades and speed control setting. In an embedded system context, you can control the fan speed and on off state using a microcontroller, allowing automation and remote controller. Digital keyboard. LED means light emitting diode. Relay. A relay is an electromechanical switch that can be controlled by a low power signal, typically from a microcontroller. Reset button. Buzzer. A buzzer is an audio output device that generates sounds when an electrical signal is applied. In embedded systems, buzzers are used to provide audible feedback, notifications, or alarms. They can produce different tones and beeps depending on the applications. Heater. A heater is a device that generates heat, often using electrical resistance or other heating elements. In embedded systems, heaters are used in various applications such as in ovens, water heaters, or climate control systems. Microcontrollers can control the temperature and operation of heaters for precise temperature regulation. These components are often integrated into various embedded systems to add functionality, control, and user interaction to device and applications. Microcontroller. Basically, the microcontroller is called when the timers, peripheral, CPU, RAM, and ROM, and all other ports are integrated in a single chip is called a microcontroller. In embedded systems, microcontroller is preferred rather than the microprocessor because the microcontroller have inbuilt timer, CPU, and RAM. So it is easy to compare the microprocessor. Microcontroller interrupts. Basically, there are two types of interrupts in microcontroller. One is hardware interrupt and another one is software interrupt. External hardware interrupts. These interrupts are triggered by external hardware signals such as button, pressure, sensor reading, or an external device sending a signal to the microcontroller. They allow the microcontroller to respond to real world events. Again, hardware is further divided into two types. One is non-maskable and another one is maskable. Maskable means we can hide the interrupt. Non-maskable means we cannot hide the interrupt by using any other sources. Again, maskable divided into two types. One is external maskable and another one is internal maskable. To create a microwave oven, there need of three basic softwares. One is MPLab software, which is used to write the C language to implement the microwave oven. Another one is XE8 compiler, which is used to compile the C programming languages, which is written in the MPLab. And another one is PICSIMLab architecture. We used PICSIMLab architecture because it consists of a microcontroller and implementation of micro ovens. This is the basic structure of PICSIMLab architecture. It contains of GPI input output ports, LEDs, buzzer, digital keyboard, SSCDs, matrix keypad, CLCDs, and A2 ADC, that means analog to DC converters. Light emitting diode. Light emitting diode is called as LED. It is a semiconductor devices. These LEDs are connected to port B and port D in a microcontroller. Basically, the microcontroller consists of four ports. One is port A, port B, port C, port D. So the LEDs are connected to port B and port D. By giving the logic 1, we can access the input like a ports. By using logic 0, we use output for the ports. CLCD. CLCD means character liquid crystal display. It is used to display the characters. There are two types of displays. One is 16:2 display and another one is 16:4 display. In this project we use a 16:4 display that displays the ASCII code characters and some special characters. It is mainly communicated in 4-bit mode and 8-bit mode. These are the switches we principle. This is the basic principle of the switches. Basically the switch pressing method is take some bouncing, so we can press at the time, it cannot respond quickly, so it takes some bounce. That's right, that means it is bouncing, so it's some delay is happening. So pull up and pull down registers are commonly used in digital electronics to ensure that a signal at an input pin has a defined voltage level when it is not actively being driven by a signal source. A pull-up register connects the pin to a voltage source, usually a high logic level like VCC, while a pull-down register connects the pin to ground, usually a low logic level. MKP means matrix keypad. Matrix keypad is a common input device consisting of multiple buttons arranged in a grid, typically in a rows and columns. When a button is pressed, it forms an electrical connection between a specific row and column, allowing the microcontroller or other controller circuitry to detect which button has been passed by monitoring the row and column lines. Matrix keypads are widely used in embedded systems and electronic devices for user input due to the simplicity, cost effectiveness. Let's we see about the programming and implementing the micro oven. This is the basic code of the micro oven. It consists of 4 header files and 3 source files and 1 is main file. This is the main file to implement the micro oven. Here the keys are defined and which key is functioning. That means defining the key of the functions, like key 1 equal to micro mode, key 2 equal to grill mode, key 3 equal to convection mode, like that. These are the displaying. Actually we talk about the maximum temperature for the micro oven in the convection mode. So here if we have high temperature, we want to change like this 250. So in my project I keep like 250. So 250 is the maximum temperature for my micro oven. So to implement the micro oven, we firstly build the file. So left click, build. Here see clearly it creates an hex file. So where it is located, the location is given here. So we want to load this hexa file in the Pixim lab. Now open the Pixim lab. First of all, it shows like this. So we want to change board into Pic Generis microcontroller. It takes some time. Microcontroller. P1 PIC1 6F877A microcontroller. So this is the micro oven structure. So basically it runs the previous code only. So again we load the exa file. So load exa file, user name, MP lab projects, micro oven, the ist, default, production, this file. Okay, let's load it and check about the result. See, power on. So we discussed previously, so there are 4 modes. One is micro mode, another one is grill mode, and third one is convection mode, fourth one is start mode. So we can change the clock in megahertz like 64, 40, 48, 32, 20, 16, 10, whatever like we want. Okay, so here there are previously talked about LCDs. So LCDs, there are 2 methods. One is 16x2, 16x4. We use 16x4 LCD to display the other board. So press 1 for micro. The power is 900 watts. We clearly mentioned previously. Here we need to set the time. Like suppose we keep it 10 seconds or 01 seconds, that's okay. And 2 minutes. Star is used to clear the time. Hash is used to enter the time and run the micro oven. Press hash. Clearly sees here the fan is running. Okay, the fan is running, so the micro oven starts. So we can use 4, 5, 6 to start, stop. So 6 we use it to stop. Okay, the micro oven is stopped like that. So suppose we said that 250 is the maximum temperature we fix it to this micro oven. So let's check it. It asks temperature, so we can enter the more than 250 like what we expecting from. So I enter 600. So I enter 600. So click hash. So invalid temperature. So previously we said the maximum temperature is 250 degrees. So now we entered in 600 degrees, so it displays temperature is invalid. So now set temperature in 100 degrees. Click enter, that means hash. So it shows the time remaining. That's all about the project. Thank you for giving me this opportunity to learn about the embedded systems.